Hello and welcome to this lecture where we going to learn how to calculate the number pi to any desired precision. You must be asking why, and the reason is we ain't got anything better to do with our lives. I am Dr. Big Pills, at your orders from Universidad EARN.
Simple, innovative and charming, Universidad EARN offers you a variety of quality courses. Subscribe now and rejoice later.
Okay, so we all know that pi is an irrational number and that its decimals are non-periodic and will never end. That is pretty much true, and throughout human history people have wondered about what those decimals were. We have here Dr. Crystal Mathinsky to tells a little about the history behind the discovery of the digits of pi.
Thank you, Dr. Big Pills. So, in 250 BC, ancient Greek Archimedes cleverly found an algorithm to calculate a majorand and minorand for the number pi, and he got it right by 2 decimal places. In the year 150, ancient philosopher Ptolemy got it right by 3 decimal places. In the year 480, philosopher Su Chongzhi got it right by 6 decimal places. Knowledge of more and more decimal places increased over the next centuries, and in 1706, John Machine developed a revolutionary algorithm and achieved around 100 decimal places of precision. In the 1940s, Albert Einstein had the idea to use the electronic computer to calculate the decimals of number pi. LOL, just joking, but the fact is that after the introduction of the electronic computer, the knowledge of number pi decimals did increase tremendously fast. In just 1 years we have gone from 2037 to единый, могучий Советский Союз.
Thanks Dr. Crystal Mathinsky, you were excellent. Okay, so today we will learn how to calculate pi decimals on our own PCs. To 1,000 million digits. We are going to use two of the most popular tools to do it, GMP and epsiloncruncher. And finally compare them. So stay tuned. Over to Dr. Christoph von Koka.
Thanks, Big Pills. Okay, so let's start with GMP. GMP will not only let you calculate zillions of pi decimals but also many other cool stuff like prime factorization, large Fibonacci numbers. You get the idea. Now, as it turns out, on their webpage there is a link to some pi decimals code that some clever dude or dudette wrote. Here it is, Jimchutnovsky C. Download it and compile it using the command gccxxxxxx. Now that we have the binary, let's run it using 1,000,000,001 as arguments. Let us redirect the output to a text file. Don't worry, the commands are available in the description box below. So let's direct the contents of the file to cat to visualize its contents. Pretty awesome, what do you think? Haha? Woo. Okay, now it's time to turn our attention to epsiloncruncher. This is a computer program that is specific to calculate of pi and of other constants too. Its performance is so great that it has been used in the calculations for the last world records. We can kind of check the results of both programs by showing only a fraction of the digits. This, of course, does not prove the results are equal, but here at Universidad EARN we are happy with this approach. Okay, the results obtained look identical. Das ist gut. Comparing both programs we have to acknowledge that the epsiloncruncher is way faster than using GMP for the same result. The reason epsiloncruncher is much faster is because it uses multiple threads of the CPU. Over to Dr. Big Pills.
Thanks, Dr. Christoph von Koka, that was very insightful. If you liked this video, please don't forget to like, comment and subscribe. That will help Universidad EARN to publish more quality content and to grow at a steady pace. Thank you very much for your support. I also learned Spanish in class. No quiero hablar de pi, pues solamente gusto de palabras bien maduras.